Inverse trig functions are something that you guys have seen before. We often use it when we're trying to find the angle. On your calculators, it's always above sine, cosine, and tangent, and it would look something more like this. This may be how you're used to seeing it. Okay? The sine of what angle equals 1/2. And so if you can remember and set up a 30, 60, 90 triangle, it's nice when you know that sine is opposite. So if this is my angle x over the hypotenuse 2, and you say, hey, I know that, that's a 30, 60, 90, where this is 30 and this is 60. Oh, x is equal to 30 degrees. Okay? But this section goes in a little bit more depth to what the inverse trig functions are, and then we'll use a couple terms that are a little bit different. Okay? The first thing I just want you to get used to hearing that the inverse of sine is not cosine, it's not cosecant. Cosecant is the reciprocal. It is what's called the arcsine function. Okay? On your calculators, it is represented by that sine to the -1. Okay? It takes as its input, its domain is numbers. For sine, that domain has to be between -1 and 1, and the range are going to be the angles. Now, what's curious is if you looked at the graph of the arcsine function, to make it a function, they had to constrain the range to say the range must be between, I'm going to do this in degrees first, -90 to +90 degrees. Okay? Otherwise, it's not a function, because if you look in your book, they'll show you a graph of it. It looks something like that. If I continued and just drew an inverse sine curve like this, notice it would fail the vertical line test. So there's this constraint on the range. It's the same also for arc cosine, but arc tangent, arc secant, arc cosecant, arc cotangent have different values. But just to understand, the domain has to be between -1 and 1. If you put something in your calculator and try to find the arcsine of like 5, your calculator is going to give you an error. And that's a good idea that you're putting something wrong in. But what we get out of doing an arc function is always an angle. So here's the important thing to know. Okay, this is where that all students take calculus comes back. I think we talked about this a little bit. If I'm setting up an arc function, so I've told you to find me the arcsine, or I write it like this, of maybe, I don't know, square root of 2 over 2. And I say don't use your calculator. I'm taking the arcsine of a positive value, so that tells me I should be setting up a reference triangle in the first quadrant, where my opposite is square root of 2, my hypotenuse is 2, and I'm looking for this angle. Now if I do the Pythagorean theorem, 2 squared minus the square root of 2 squared, I'll get 4 minus 2, or 2, and so this becomes the square root of 2. Now hopefully you recognize that since both of the legs are the same, that it's a 45, 45, 90 triangle, and x is equal to 45 degrees, or pi over 4 if you're doing it in radians. Okay? Depending on what mode you have your calculator set in, they'll give you either this answer or that answer as a decimal. They won't usually put the pi symbol in there. This is the same thing as 1 square root of 2. Okay? If I multiplied all three of these values by square root of 2, that's what I'm going to get. So here's the key. No matter what arc function you're taking, if it's a positive value, it's always going to be in the first quadrant. Now, suppose I was doing arcsine, so I'm going to write it like this, of -1/2. Now, I have to think to myself, where is sine negative? Well, sine is positive in these two quadrants, so sine is negative down here. The quadrant that I want to go to is, if I'm starting at 0, which one's closest? And so the answer is the fourth quadrant, and so I would set up my reference triangle like that, and I'd think the opposite is 1, the hypotenuse is 2, but somewhere in there I have to have a negative. Well, you should see, because I'm going down, that one has to be negative. And again, either through Pythagorean theorem or just knowing my triangles well, I know that that's 30, or excuse me, square root of 3. That's 30. This is 60. Since I went down, the answer to this would be negative 30 degrees. Okay? Remember I told you the range for arc sine is from negative 90 to 90. So I would not say it's 330 degrees and go all the way around. That's taking way too far. If I did the same thing with arc cosine of negative 1/2, I'm going to have my setup be entirely different because cosine is not negative in the fourth quadrant. It's negative in the second and third. And so whoever the powers that be decided, you know what, let's set it up over here in the second quadrant. So I'm trying to figure out that angle, and I have adjacent over hypotenuse. And again, something's got to be negative. Since I went to the left, it's the adjacent side. The hypotenuse is never negative. It's always positive. So again, knowing my triangles, I can say that that's square root of 3. And 30 is across from the 1. 60 is across from the square root of 3. So is my answer going to be 60? No, it's how many degrees does it take for me to get here. So that's going to be 180 minus 60, or 120 degrees, which is the same as 2 pi over 3 radians. Okay? So here's, again, the key. When I'm setting up arc cosine of a negative, I'm up here in the second quadrant. When I'm doing arc sine, I'm in the fourth quadrant with a negative angle. If I did arc tangent, it's the same. Both of these are negative, and so it follows the lead of sine, and it goes to the shortest and closest one. So if I said to you the arc tangent of negative 1, then automatically I would set up my reference triangle down here where I would say, okay, that's the same as negative 1 over 1, so opposite over adjacent, and I have to have negative. It's got to be this one because I'm going down. And so the angle that I'm looking at, hey, that's a 45, 45, 90. So if that's 45 degrees, to actually get down then is negative 45 degrees. Okay?